mathematicians, this is Mrs. Shopper coming with you with trapezoids and kites. These are going to be the last quadrilaterals that we're going to be talking about in this chapter. So here we go. What are some important vocabulary words? Slowly coming. There we go. Trapezoid. It's quadrilateral. It has one pair of parallel sides. So far, we've been talking about a lot of figures that have two pairs. Trapezoids only have one. The bases are those parallel sides. The legs are the non-parallel sides. The base angles are formed by the base and one of the legs. Okay, so in a parallelogram, let's say that this is my parallelogram. Okay, it's formed by the bases and one leg. So like, and one of the legs. So this would be like a base angle right here. Okay, isosceles trapezoid. They have congruent legs. Keep that in the back of your mind. You're going to be seeing that as we go through this work. All right, so an isosceles trapezoid, let's talk a little bit more about it, okay? Each pair of base angles is congruent, okay? If a trapezoid has one pair of congruent base angles, then it's an isosceles trapezoid, okay? All it has to have is one pair. If it is a isosceles trapezoid, then both are going to be parallel, but you only have to know one to state that it is an isosceles trapezoid. And a trapezoid is isosceles if and only if its diagonals are congruent. So in an isosceles trapezoid, diagonals are congruent. In a trapezoid that is not isosceles, meaning the legs aren't the same length, then the diagonals are not congruent. All right, so here we go. This is a basket, okay? Each side of the basket shown is an isosceles trapezoid. So this trapezoid right here is isosceles, okay? That means that JM and KL are the same measurements, okay? If the measurement of JML, this angle right here, is 130 degrees and KN is 6.7 feet and LN is 3.6 feet, we need to find the measurement of MJK. Well, in a quadrilateral, you have 360 degrees, total 360 degrees, okay? We know that if it's a trapezoid, if it's an isosceles trapezoid, that both the JMK and KLM are going to be congruent. So I've got 130 degrees plus 130 degrees plus these measurements right here are also going to be congruent. So I'm going to say 2 times x. Now that's going to equal 360 degrees. Okay. So if we subtract 260 from both sides, we're going to get that 2x is 100. So x equals 50. Okay. So if x equals 50 and x represents MJK, we're totally good. All right. Now we need to find the measurement of MN. So in this triangle, the diagonals are congruent. Therefore, their endpoints are equidistant from where they meet. Their meeting point, their intersection point isn't the midpoint, but we can say that LN and MN are the same. So MN is going to be 3.6 feet. Okay. All right, we need to say whether or not this figure is an isosceles trapezoid. So we know that it's a trapezoid. We just have to determine if it's isosceles. So we need to know if the legs are congruent. So I'm going to go over 5, up 1. I'm going to go back 3, down 1. I'm going to go back 2, down 3. I'm going to go over 2 and up 4. All right, so here's my figure. I'm just looking to make sure I did this right. Nope. It should be -2, 3. So -2, up 3. There we go. And then B should be -3, 5, over 5. 1, 2, 3. There we go. I see where my mistake is. Perfect. All right. There we go. So here's our trapezoid. Okay. All right. We never want to say looks like to determine which side are the bases. I mean, it clearly looks like these two are, but we're going to prove it mathematically. And so then I've got A here and B here and C and D. So the slope of DC is going to be 4 minus 3 over 2 minus negative 2, which is 1/4. And then BA, the slope of BA is going to be 1 minus negative 1 over 5 minus negative 3, which is 2 over 8, which is 1/4. So we need to prove which sides are the parallel sides. We can't just say it looks like, okay? So we're kind of beyond that when we get to the level of math that we're in right now. We got to be proving this stuff. All right, so now we need to know if it's a trapezoid, isosceles trapezoid. So we're going to check to see, are these two sides going to be congruent? Do they have the same measurement? So the measurement of CB is equal to the square root of the quantity, -3 minus -2 squared plus -1 minus 3 squared. So the square root of 1 squared plus 4 squared. So the square root of 17. I think I did that right. Let me just double check my math again. -3 minus -2, -1 minus 3. Yep. All right. So now we're going to go ahead and do that with dA. What's the measurement of dA? It's the square root of the quantity 5 minus 2 squared plus 1 minus 4 squared. So it's going to be the square root of 3 squared plus 3 squared, which is equal to the square root of 18. Okay, well, those two aren't the same measurement, so therefore it is not an isosceles triangle. Yeah. All right, here we go. New theorem, trapezoid midsegment theorem. If BE is the midsegment of the trapezoid, then we can say that these two sides are congruent and these two sides are congruent. We can also say, look at this, that the midsegment is half the length of the sum of the two bases. I want to remember that. Get this down on your note card. Okay, so how does this put this to work? And again, you can be pausing the videos through this. That's why I'm going a little bit quicker in the video. Okay, it's an isosceles trapezoid. JK is 18. WZ is 25. So how do we find XY? So what we can say is that 18 is equal to 1/2 of 25 plus X. And now we have an equation to solve. I'm going to multiply both sides by 2, so 36 equals 25 plus X. So X is 11. Okay, using that information. And then lastly here, we've got the kites. Kites have diagonals that are perpendicular. They have exactly one pair of opposite angles congruent. Okay. Its diagonals are perpendicular. The other piece of a kite that you see in this picture is it has two consecutive congruent sides. Two consecutive congruent sides. All right. Here you go. Find WX, if it's a kite, find X, Y, Z. All right, so I've got these two are my congruent sides. So I have 360 is equal to 73 plus 121 plus 121 plus X. So 360 is equal to 242 plus 73 plus X. So 360 is equal to 315 plus X. X equals 45 degrees. Because the sum, again, building on that, is 360. All right, we got to find NP. Ooh, bring in Pythagorean's theorem back. Because NP and MN are the same length. And so we know that they meet at a right angle. So I can use Pythagorean's theorem. 6 squared plus 8 squared equals c squared. And 6, 8, that's part of a Pythagorean triple. It's actually part of 6, 8, 10. So 36 plus 64 equals c squared. 100 equals c squared. So c is 100. There we go. All right. Your homework is to do page 444, 8 through 18. All right. Have a great day. We'll see you later. Adios. Bye-bye.